Welcome to the ET302 how-to video for the 555 timer lab. Here we are at Multisim, and I have given you this file which has a monostable timer. And on this leg here, this is our trigger, and we're going to close this key quickly and it should start our timer. This is a decoupling capacitor, so its size is fixed, and this leg here has a 10 microfarad capacitor and a 50k ohm resistor. And I'm using 9 volts. The 555 works at a very large range. I've got an LED or probe here, and I got our Tektronix scope. And I changed the 100 to a 10 because the simulation lasts too long. Works for real components, but our simulation takes too long to do this. So let's go ahead and start it. Okay, let's open up our oscilloscope and let's clear it. Okay, and we are going to use single sequence, so it'll latch it. And let's go ahead and start. So what we're going to do is click on the page, and we're going to quickly hit the space bar, which is going to close our switch, and it's going to start our monostable. A monostable is a one shot, so it's going to produce a one pulse, and good, it stopped. So what we have here is our output pulse, which is based on these two components, and we could calculate what that should be. The blue here is the charge pattern of our capacitor. It's a standard charge wave, and it's about 2/3 of our total, which is correct. So what we can do is we could estimate by moving this. We can estimate our time. So we got 100 milliseconds per division. So we got 1, 2, 3, 4, 5, and maybe a half. So about 550 milliseconds, which is a little over 1/2 second. Another thing we could do is let's go ahead and go to measure. And we can, let's go to positive width, and we have 548 milliseconds, which was a pretty good estimate on my part. Okay, so that's our first one, and we could go ahead and double click on our components and change them in order to do our measurements. Good. Okay, so let's shut down our simulation. And let's open up our next file, and we're not going to save it, and we're going to use our astable. Astable means a continuous waveform. So this one is going to put out a continuous pulse, and we could control both the positive width and negative width and the frequency, and that's all based on these three devices here. So we have two resistors and a capacitor. This is our decoupling, so it doesn't affect it. So let's go ahead and start here. So let's turn it on, open up our oscilloscope here, and let's clear it, run stop, and let's go to single, and let's go ahead and let's run it. Let's take a look at the waveform here. So we're going to change our time. There we go. And let's go ahead and do a single sequence. Good. So what we have here, this is time high. This is time low. The total time would be the period here. And this would be our charge of our capacitor, and this would be our discharge. And we notice here that it goes between 1/3 of the charge to 2/3 of the charge. So it resets at those 2 points, and we end up with a continuous wave. And the voltage should be very close to the input voltage, 9 volts, and it looks like it is. So let's go ahead and do some measurements here. Let's go to measure, and let's do positive, channel 1, because that's what we're using. And let's do positive width. Good. Let's go to back, go to the next one. So we're going to do negative width. Good. And we're also going to do period. Period would be the total time. Here we go, period. Action, let's do frequency, because that's what we're controlling also. Good. So what we have here is 138 milliseconds high, 69.6 low. Our period would be a combination of these two added, 208, and our frequency would be 4.8 hertz. So this looks good. So if we need to change, we need to turn off our simulation, and we could change these 3 values here in order to match the lab. Good.